Hello, Matt here from chemistrystudent.com. In this video, we're going to look at how to balance reaction equations. Reaction equations are an essential part of chemistry. They allow us to easily represent reactions and show how the formulas of reactants change as they are turned into new products. They also show us the ratios of reactants to products in a reaction, how many reactant particles are needed compared to product particles produced. The problem is that when writing symbol equations for a reaction, things can get difficult as the total number of atoms of each element has to be the same before a reaction as after. No atoms can be created or destroyed in a chemical reaction. This is called the law of conservation of mass, meaning the formulas for each reactant and product in a reaction equation must balance out in total to make sure the total number of atoms of each element in all the reactants is the same as the total number of atoms of each element in the products. Easy in theory, but can be a bit difficult in practice. For example, hydrogen gas reacts with oxygen to form water. The formula for hydrogen is H2, oxygen O2 and water H2O. Note, it's impossible to balance equations if you don't know the correct formulas of everything involved in the reaction. So always make sure you've got your formulas correct before you try balancing. For our example here then, H2 plus O2 equals H2O. The problem is this isn't currently balanced, so how can we balance it up? Well, we first need to write out the total number of atoms of each element on both sides of the equation. On the left, we have 2 atoms of hydrogen from H2 and 2 atoms of oxygen from O2. On the right, we have 2 atoms of H from the H2 part of H2O and 1 atom of oxygen from the O part of H2O. Currently, the number of hydrogen atoms on both sides are the same. Great, they're balanced. However, the oxygens aren't. To balance the oxygens then, we need to get 2 oxygens on the right to match the 2 on the left. The only way to do this is to make 2 lots of H2O. We can't change the formulas in the equation. For H2, O2 and H2O must stay the same. In other words, we can't change those small subscript numbers. We can only change the big numbers in front of each formula. These big numbers are sometimes called the coefficient. Back to our example then. If one H2O molecule gives 1 oxygen atom, we need 2 H2O molecules to give 2 oxygen atoms. This would now give us H2 plus O2 equals 2 H2O. Let's recheck our atom numbers. 2 times hydrogen on the left, 2 times oxygen on the left. Now, however, we have 4 times hydrogen on the right and 2 times oxygen, as 2 lots of H2O would give 4 times H and 2 times O in total. Now the oxygens balance out on both sides, but the hydrogens don't. I know, it's a really annoying process this. To get 4 lots of hydrogen on the left side, we would need 2 lots of H2, as 2 lots of H2 give 4 times hydrogen in total. This would now give 2H2 plus O2 equals 2H2O. Final check. On the left, 4 times H and 2 times O. On the right, 4 times H and 2 times O. Great, we're balanced. It can be really tempting to skip steps and to try and do this all in your head, and before long you'll be able to. However, I strongly recommend writing your steps out. There are no awards for doing everything in your head, and you just make it more likely that you'll make a mistake. Practice really is vital. Let's look at another example. Methane CH4 can react with oxygen, O2 forming carbon dioxide, CO2 and water, H2O. This would give CH4 plus O2 equals CO2 plus H2O. Time to balance. On the left, we are starting with 1 times C, 4 times H and 2 times O. On the right, we're starting with 1 times C, 2 times H, 3 times O. From this, we can already see the carbons are balanced, 1 atom on each side. This means for now we want to leave the CH4 and CO2 alone, as if we change them we lose the balance of the carbons. This means we need to get 4 hydrogens on the right. Well, that would mean we need 2 lots of H2O. As if one molecule of H2O has 2 hydrogens, then 2 molecules of H2O would have 4 hydrogens in total. Now giving us CH4 plus O2 equals CO2 plus 2 H2O. On the left, 1 times C, 4 times H, and 2 times O. On the right, 1 times C, 4 times H, and 4 times O. Looking good. The carbons and hydrogens balance. It's now just the oxygens left to sort out. On the left, there are 2 times O, and on the right, 4 times O. This means we need 2 lots of O2 on the left to give 4 lots of O in total. This would mean CH4 plus 2O2 gives CO2 plus 2H2O. Always give a final check. On the left, 1 times C, 4 times H, and 4 times O. On the right, 1 times C, 4 times H, and 4 times O. All balanced, hey presto, you're done. I hope you found this video useful. Please check out other relevant videos in the links given in the description below, and visit chemistrystudent.com for free notes and revision materials.